Hello guys, in this video we are going to discuss the solution of the problem count smaller elements. So let us look at the problem statement. The problem statement says given an array ARR containing positive integers, count and return array answer where answer I denotes the number of smaller elements on right side of array ARR I. So for instance, if this is the array which is given to us, so for the first element, which is 12, the number of elements which is smaller than 12 are 6, which is these 6 elements, because of which this is 6. Similarly, for the second element, which is 1, the number of elements which is smaller than 1 is just one element, which is 0, because of which this is 1, and so on for the rest of the elements. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So to solve this problem, the concept which we are going to use is merge sort. And while performing the merge sort, we will count the number of elements which is smaller than the current element. So let us take an example to understand this. And just one more thing, we are going to sort the array in descending order. So now let us take an example to discuss the merge sort, and while performing the merge sort, we will see how we will be able to achieve the second part, which is count the number of elements which is smaller than the current element. So let us take an example. So let us say the array which is given to us is this. So let us say this is the array which is given to us. Now as in merge sort, the first operation we are going to do is we are going to divide the array into two equal parts. So let us do that. So the first half will be 12, 1, 2 and 3, and the second half will be 0, 11 and 4. So now let us recursively divide these arrays till the size of individual array becomes 1. So let us do that. So in this way, we have divided the entire array. So once we have divided the array, now let us perform the merge operation. And now while performing the merge operation, we will go ahead and count the number of elements which is smaller than the current element, and we will keep on updating this value into our answer array. So let us see how we can do that. So let us merge these two arrays. Now remember, we have to merge the array in the descending order. So once we merge these two arrays, the array will become 12 and 1. While performing the merge operation, we are comparing whether the current element, which is this element, is greater than the next element or not. So if the current element is greater than the next element, then we are going to count the number of elements by which the current element is greater than. So over here, as we can see, there is just one element by which 12 is greater than, because of which right now in our answer list, so let us say we have our answer list. So let us say this is our answer list, and just to have the values proper, so at 0th index the value was 12, and so on over here it was 2, 3, 0, 11 and 4. So as of now, what we have observed is we have observed that 12 is greater than just one element, because of which corresponding to 12 we are going to put a value 1 over here, and the default or the initial value for all these elements is 0. Now let us proceed forward. So when we combine these two arrays, as of now 2 is not greater than 3, because of which we are not going to update our entry. Since this is just one element, so this 0 will come over here. Similarly, when we are combining these two elements, then we realize 11 is greater than 4, and the number of elements by which 11 is greater than is just one element, because of which corresponding to 11 we are going to mark an entry 1 over here. So corresponding to 11 we will have 1 over here. Now let us proceed forward. Now after merging the first layer, now let us go ahead and merge the second layer. So now we are merging these two elements. I'm so sorry folks, this we are arranging the elements in descending order, so this should be 3, 2, not 2, 3. Now when we are merging these two elements, then we realize that 12 is greater than 3. Now since 12 is greater than 3, then 12 will come first, but we will also go ahead and count the number of elements by which 12 is greater than. So the number of elements by which 12 is greater than is these two elements, right? Because of which we will go ahead and increase this value by 2. So this value becomes equals to 3. So after operating on 12, let us move to the next element. So our next element is 1, and since 1 is less than 3, because of which we will not update our answer list. So 3 will come over here. Again, the next element is 1 and 2. So 1 is less than 2. So again, answer will not be updated and 1 will come over here. And in this way, this half of the array has been sorted in descending order. Now let us do the same thing on this array. Again, 0 is less than 11, because of which the answer will not be updated. 0 is less than 4, because of which answer will not be updated, and the list will become something like this. Once we have this, now let us merge these two arrays. So now let us merge these two arrays. So 12 is greater than 11. So 12 will come first, and we will see how many numbers by which 12 is greater than. So the number of elements by which 12 is greater than are these three elements. So this value will be increased by 3, and this becomes equals to 6. Now let us proceed forward. So 12 we have operated on. Now the next value is 3 and 11. As 3 is less than 11, because of which 11 will come over here, and we will operate on the next element. Again, 3 is less than 4, so 4 will come over here, and we will operate on the next pair, which is 3 and 0. So over here, as we can see, 3 is greater than 0, because of which 3 will come over here, and corresponding value of 3 will be increased by just 1, because 3 is greater than just one element, which is 0. So let us increase the value corresponding to 3 by 1. So this value becomes equals to 1. So 3 we have operated on. The next pair is 2 and 0. Again, 2 is greater than 0, because of which 2 will come over here, and the value will be increased by 1. So this value becomes equals to 1. The next pair is 1 and 0. So 1 is greater than 0, because of which 1 will come over here, and the value corresponding to 1 will get increased by 1. So this value becomes equals to 1. There is no element, so 0 will come over here. And in this way, if you see, we have sorted the array in descending order, and while sorting the array in descending order, we have populated this value as well, and the remainder value is 0, since the default value is 0. And in this way, we will be able to get to our answer. So that's the discussion of solution, folks. Now let us discuss the pseudocode for this problem. So let us say we want to construct a lower array. So the first thing which we are going to do is we are going to take a temporary array, and we are going to take an answer array. And as we have discussed, the default value for answer array will be 0. And once we have these two, now let us populate our temporary array. And in the temporary array, what we are going to do is we are going to store a pair of array I, I. So each element of this temporary array will have a pair which is array of I, I. And the reason why we need a pair to be stored in an array is because when we were operating on this merge sort, as you have seen, when we were trying to populate the correct value for 12, we were looking into this array and we were trying to find out the index where 12 is and the corresponding value we wanted to increase. So in order to optimize our algorithm and in order to find the entry of 12 in order of one time, we are restoring its index as well, so that we will just go ahead and pick this index and we will come into our answer and we will update the corresponding entry. And this we can do it in order of one time if we store index along with the value of the array. So because of which we are storing array of I, I in temporary array. So let us do that. So in this way we will be able to populate our temporary array. Once we have populated our temporary array, then we will go ahead and perform merge sort. And to perform merge sort, all we have to do is we have to pass our temporary array which need to be sorted, and also the answer list, since the answer has to be updated, along with it the starting index which is 0 and end index which is len of array minus 1. And once we have performed our merge sort, then we will go ahead and return answer. Now let us look into merge sort. So let us say we want to perform merge sort. An array is given to us, an answer list is given to us, start pointer and end pointer is given to us. So the first condition is if start is less than end, then we are going to compute the midpoint, which is equals to start plus end minus start divided by 2. Now once we have the mid pointer with us, then we are going to perform merge sort on the first half of the array. So start to mid, which is the first half of the array, and similarly merge sort on the second half of the array, which is mid plus 1 to end. And in this way, we will be able to perform the merge sort. Once we have merge sort these two arrays or the two halves of the array, then we will go ahead and perform the merge operation for the array and the answer list from start to mid, then to end. Now let us look into the merge function. How do we define the merge function? Because this is the function where we are actually going ahead and performing the sort operation, as well as we are populating the answer list as well. So let us look into the merge function. So let us say we want to merge two halves of the array, and array is given to us, also the array list, also the answer list. Starting position, mid position, and end position of the array is given to us. So the first thing which we are going to do over here is we are going to take an ith counter, and initial value of ith counter is s. Similarly, jth counter, and the initial value of jth counter is m plus 1. And also we are going to take a temporary list. Now we will operate on I and j while I is less than and equals to mid, the first half of the array, and j is less than or equals to n, which is the second half of the array. So the first thing which we are going to check is if array I comma 0. So remember, each element of array contains a tuple. So this has each value of array will have array of I comma I. So this is what we have in the array. Each element of array has these two entries. So what we want to do is we want to compare this value. So that is why array of I comma 0 is greater than array of j comma 0. If this is greater, then we have obtained the greater value. And once we have obtained the greater value, then we need to update our answer list. So let us update our answer list. And which index of answer has to be updated? Well, the entry will be, or the index will be given by this value, which is array of I comma 1. And that is the reason why we were storing index as well as value in our temporary array. So let us have that array of I comma 1, and this value has to be increased by the number of elements this element is greater than. So how many elements this value is greater than? Well, this is e minus j plus 1, right? So let me explain this part. So let us say these are the two halves of the array, and this is my ith pointer and this is my jth pointer, and this is mid pointer and this is my end pointer. Now if this value, let us say this value is x and this value is y. Now if x is greater than y, then we want to find out how many elements are there by which x is greater than. So the number of elements by which x is greater than are all these elements, right? And how do we find the number of elements over here? Well, the number of elements will be found out by end minus j plus 1. And that is what I am doing over here, which is end minus j plus 1. Now once we have populated our answer list, what we are going to do is we are going to append array I in our temporary element. So temporary element is nothing but a temporary sorted array. And we'll see in a bit how we will be using this, but for now let us proceed forward. Once we have done that, we are going to update our I by 1. And for the case where this value is not satisfied, for such case we realize that this value is greater, because of which we are going to push this value in the temporary array, and we are going to update our jth pointer by 1. And in this way we will be able to iterate on all the elements of the array. However, it might be possible that there still exist some elements from the ith value. So for I is less than or equals to mid, so if there exists some values, then we'll simply go ahead and put these value into the temporary array as we do it in the regular merge operation. So array of I, and let us update our ith counter by 1. And similarly, it might be possible that there exists some element in the second half of the array. So under such case, this value will be true. And in such cases, we will just go ahead and update or append these values into the temporary array. And in this way, we have sorted the array in descending order. Once we have sorted the array in descending order, so remember the sorted array is in the temporary array. Now we will take the temporary array and we will put it into the array, existing array. So let us do that. So for that, I is equals to start and j is equals to 0. So I equals to start is for this start a counter in this array, and j equals to 0 is a counter in this array. So now and we simply have to do array of I is equals to temporary j. And once we have done that, we will update our I pointer by 1 and jth counter by 1. And in this way, we have sorted the array as well as we have updated our answer list also. And towards the end, this is what we are returning over here. This is the answer which we are returning. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So to implement this, we took a temporary array and an answer list. And then in the temporary array, we have stored a tuple which is array of I comma I. Now we are performing merge sort operation on the temporary array. So this is the merge sort function which we have. The first thing which we did is we have divided the array into two parts, and then we are performing merge sort operation on those two parts. So once we have divided the array into two parts, then we are performing the merge operation. Now let us look at the merge operation. So for merge operation, we took a temporary array, then we set two counters I equals to start and j equals to mid plus 1, and then I is less than or equals to mid and j is less than or equals to n. Till that position, we are iterating on the array. If ith element is greater than jth element, then we are updating our answer as well as we are putting these values into the temporary array, and then we are updating our ith counter. Otherwise, the jth value is what we are putting into the temporary array and updating our jth counter. Now after this loop breaks, it might be possible that there exists some element in the first half of the array. Those elements we are simply putting it into the temporary array. Similarly, it might be possible that there exists some elements in the second half of the array. In such case, we are putting those elements in the temporary array. And towards the end, we are updating our array so that the array becomes sorted. And then, as you can see, we are returning our answer list. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.